Building complex software on a standard personal laptop introduces immediate physical friction for a solo developer. If you are coding an application, you rely on an IDE. An IDE, or Integrated Development Environment, is the main software suite where programmers write, test, and debug their code. The physical toll of running these heavy environments natively alongside local AI tools manifests as extreme thermal throttling. Your laptop heats up, the cooling fans run at maximum speed, and the internal components struggle to keep pace with the computational demand. This split-screen bar chart visualizes exactly where that compute bottleneck happens. On the left, a standard local setup routinely consumes over 16 gigabytes of RAM, which is the short-term memory your computer uses to handle active tasks. This massive load comes from running Android Studio, the official software for building mobile apps, alongside Gradle, an automated code compilation tool, and an emulator, which simulates a mobile phone on your screen. On the right, a Cloud VM agent requires 0% of your local memory. When your local hardware hits that 16 gigabyte ceiling, your workflow halts. Keystrokes lag, compiling code takes minutes instead of seconds, and your immediate productivity drops as the machine fights to process the backlog of operations. Purchasing a massive, expensive new laptop with 64 gigabytes of RAM ignores the structural inefficiency of forcing one machine to handle all the processing weight. Throwing hardware at the problem addresses the symptom, while altering your system architecture addresses the actual bottleneck. The structural shift relies on a concept called a virtual machine, or VM. A VM is a software-defined computer that operates entirely inside an isolated, remote data center, utilizing its own dedicated processors and memory. The defining question for solo developers is no longer whether to utilize artificial intelligence. The critical decision is determining exactly where the physical compute process takes place. The specific alternative to local compute is utilizing cloud-based AI agents operating within persistent remote environments, such as Genspark's Cloud. Cloud is an autonomous AI assistant designed to navigate web interfaces and execute multi-step tasks on your behalf. These cloud environments are pre-equipped with their own web browsers. The agent can visually inspect pages, click specific elements, log into developer accounts, and systematically scrape data, exactly like a human user would, entirely separate from your local network. We need to evaluate the strict operational trade-offs of moving your core project logic to a cloud VM. By weighing the metrics of resource load, multitasking, and security, we can determine if a hybrid workflow solves the hardware constraints of the solo developer. This comparison matrix establishes the evaluation framework needed to objectively weigh the operational costs of local versus cloud workflows. Maintaining immediate visual feedback for user interface tweaks requires running the heavy IDE locally. The direct outcome of this input is rapid battery drain and severe machine slowdown. Offloading heavy search and compilation tasks to a Genspark Cloud VM shifts the processing burden entirely to a remote server. This leaves zero load on your laptop's battery or processor. There is a strict trade-off regarding task persistence. In a local workflow, the moment you close the lid of your laptop, all running processes terminate. Any synchronous work halts immediately until you physically open the machine again. Assigning complex data research to a cloud VM reverses this limitation. The task runs continuously in the background on the remote server, completely independent of whether your local laptop is awake, asleep, or powered off. Preserving your local battery life while gaining 24/7 continuous runtime severs the link between your physical hardware and your project's progress. A single developer can generate output at a volume previously restricted by hardware limits. These architectural choices directly dictate human workflow and your capacity to multitask. Local development is strictly synchronous. The human operator must be present, awake, and actively managing the screen to generate any output. The alternative is cloud-based asynchronous multitasking. You can assign an agent to scrape medical vocabulary from external websites, format that data into a JSON file, and review secondary software documentation, all simultaneously. JSON, or JavaScript Object Notation, is a lightweight text format used for storing and transporting data. This advantage does carry an upfront operational cost. You must invest the initial time learning how to properly prompt, manage, and queue tasks for an autonomous agent so it understands the exact parameters of your project. For a time-poor professional balancing a full-time career alongside software development, separating your physical presence from the work is the ultimate multiplier. You queue the tasks during your limited free hours, and the agent executes them while at your day job. The final evaluation metric covers system access, architectural security, and privacy. Integrating an AI agent directly into your local environment introduces an inherent vulnerability. Granting an agent the root permissions required to write code locally means it has read and write access to your entire physical hard drive. This system topology map illustrates the alternative: privacy by isolation. Privacy by isolation is an architectural security model where experimental processes run in a quarantined environment. By utilizing a cloud VM, you place a solid firewall barrier between a remote sandbox and your secure local laptop drive. The protective outcome is absolute. If the experimental cloud environment acts erratically, executes a bad script, or suffers a critical crash, the damage is contained to the remote server. Your local machine remains entirely untouched. This architecture introduces minor operational friction. You must spend a few extra moments securely transferring the verified data files from the isolated cloud back into your local project folder before integrating them. Guaranteeing true system stability requires a physical and architectural gap between experimental AI research and your core local data. Applying these metrics to a practical workflow reveals that developers do not need to choose strictly one environment or the other. This flowchart illustrates the hybrid workflow, dividing tasks by their ideal compute environment. First, retain immediate feedback interface design locally. Adjusting XML, Android's visual markup language, requires instant visual updates. Second, export heavy data parsing, logic, and research to the cloud VM. By splitting the project logic along these strict architectural lines, you isolate tasks to their most efficient compute environment. You achieve maximum operational output without pushing your local hardware toward thermal failure. Identifying exactly who stands to gain the most leverage from this dual environment structure clarifies its value. This setup is the exact solution required for hardware-constrained solo developers. It provides a direct method to bypass local RAM limits and compile large projects without purchasing new machines. It is also essential for moonlighters. Moonlighters are professionals who build personal projects in their off hours while maintaining a primary day job. They require a system that pushes project progress forward asynchronously while they are occupied at the office. There is a strict counterexample. Enterprise developers operating offline within lockdown corporate intranets should avoid this structure. Introducing unnecessary external cloud network dependencies violates tight corporate security protocols and adds latency where powerful local servers already exist. Mastering modern software development no longer requires acquiring the strongest local hardware. The highest leverage comes from a hybrid compute strategy, weaving together the immediate control of a local machine with the asynchronous power of the cloud.